Hi, I'm Frankie, and in this video we'll be looking at hot water systems. Hot water systems in commercial buildings are used for a variety of reasons and can be supplied in a number of ways. This video will take a look at some of those systems and explain some tips on how to make them run more efficiently. There are 4 ways that hot water systems can be made more efficient. You can use less water or eliminate hot water altogether if it's not required. You can improve the efficiency of the heating of the water itself or use renewables to contribute some of the energy required. You can reduce the losses from storing the hot water, and you can reduce the losses from distributing the hot water around your building. I'll focus on the efficiency, storage and distribution aspects in this video. The type of system you have will largely depend on the amount of hot water your business requires. For businesses where there is a small hot water requirement for activities such as hand washing, smaller electric systems will be appropriate. These are instantaneous electric water heaters close to the point of use. They work well for occasional hand washing, but the flow rate is quite limited, so it's often more practical to install a type that has a small integrated storage vessel. Modern units are well insulated, and because they can be installed very close to the tap outlets, pipework energy losses are also minimised. They can usually serve a few hot tap outlets and so are often described as multi-point units. You can get gas-fired multi-point heaters as well as electrically powered ones. Gas can work out cheaper to run, but they're more expensive to install and maintain. Also, as the electricity grid continues to decarbonise, there are environmental advantages to using electric instead of gas for water heating. Many people are familiar with domestic combi boilers. These produce hot water instantaneously, usually by using a high-powered gas burner. Although modern condensing combi boilers often have really impressive efficiency figures of 92% or more, those figures tend to apply to the space heating part of the boiler, and for heating water, the efficiency is often much lower. In buildings where there's a higher demand for hot water, it's common to find a centralised hot water storage cylinder in a plant room. These are often referred to as calorifiers, and sometimes have an indirect heating coil in them which is supplied with heat from a commercial boiler, but some calorifiers are directly fired by a gas burner. In this type of system, it's common to have a secondary circulation circuit, and it's here that there may be ways to improve energy efficiency. When stored hot water needs to be distributed to tap outlets that are some distance away, a circulation system gets that hot water to the tap outlets quickly. With this arrangement, hot water from the top of the storage cylinder is circulated through a pipework loop that runs past all of the hot taps and returns back to the cylinder. The hot taps are then teed into the circulation loop as shown in this diagram. This system works by getting the hot water to the taps quickly, but it can also waste a lot of energy as heat is continuously lost from the hot water storage cylinder and the circulation pipework, even if that pipework's insulated or lagged. Also, the extra pump that is required consumes electrical power. If the hot water is only being used for hand washing, a system like this may be unnecessary, and good savings can be made by using instantaneous hot water heaters at the point of use instead. Another simple way to save energy in this setup is to add a time switch to the secondary circulation pump so that it only runs when there is demand during the hours that the building is occupied. As an alternative, high-efficiency secondary circulation pumps with integrated variable speed drives and night setback functionality can be installed. Taps accidentally being left on can waste lots of hot water and therefore energy. If this is a problem in your business, you can replace taps with self-closing or sensor-activated taps. If your business uses a lot of hot water, it may be worth considering a solar thermal hot water system. There are several different kinds of solar thermal systems suitable for commercial premises. They use flat plate or evacuated tube solar collectors to convert the infrared energy in sunlight to heat a fluid which is circulated from the collectors through a heat exchanger. They're very efficient but need a backup heater for the winter months and have to be regularly maintained. They come in 2 main types. Evacuated tube collectors. These look like rows of tubes, and the solar collector plates are contained within vacuum insulated glass tubes. Heat losses are minimised through the use of vacuum insulation, but these collectors are less robust than the flat plate type. Flat plate collectors. These can be mounted on A-frames on the flat roof or integrated into a pitched roof. The absorber plate is under a glass cover and has a special coating to improve the absorption of solar energy. Another low-carbon alternative that you could consider is a heat pump. Heat pumps are normally associated with space heating, but they can also be used as an alternative way of producing hot water. The capital costs are relatively high, but if large volumes of hot water are required, they can be a good option. Ground source or air-to-water heat pumps with a storage cylinder extract heat from the ground or air and pump it via a heat exchanger into the hot water system. This process is very efficient compared with direct electrical heating, but the temperature of the water from heat pumps is usually a little too low for sanitary hot water production, and electric immersion heaters are normally required to bring the water up to a safe and hygienic temperature. Some industrial equipment and processes generate large quantities of waste heat. There are various options for recovering some of this heat, and it's quite common to use it to preheat hot water systems. All hot water systems need regular maintenance to ensure they operate safely and efficiently. Minor leaks or dripping overflows should be investigated immediately because they could quickly become worse or lead to a failure of the system. Any thermostatic blending valves that are installed to prevent scalding need to be properly maintained to ensure the ongoing safety of the installation. Unvented hot water systems need to be maintained in accordance with Part G3 of the building regulations to ensure that the safety devices remain operational. If water in an unvented cylinder is heated to the point where it flashes to steam due to a control system fault, the cylinder could explode violently if the safety devices are not working. If you have an unvented hot water system, you need to have it checked annually by a competent person. If you live in a hard water area, this can cause heat exchangers to scale up and become inefficient. It may be necessary to consider some form of water conditioning, such as a softener, to avoid this. Another safety consideration is the risk of Legionella bacteria in your hot water system. In systems where water is stored at temperatures between 20 and 45 degrees Celsius, there's a risk of harbouring or proliferating Legionella bacteria. Hot water systems should be set up to provide sanitary hot water at 55 degrees Celsius or more to avoid this possibility. However, it is imperative that a suitably qualified and experienced engineer is appointed to design modifications to hot water systems, and that a competent contractor is commissioned to carry out the alterations. It is also important to ensure that documentation and plant maintenance procedures are updated after the installation takes place. The Health and Safety Executive gives detailed guidance on the control of Legionella bacteria in Approved Code of Conduct L8. Hopefully this video has made you more aware of the steps you can take to improve the energy efficiency of your hot water system. Please take a look at our other videos to see what other steps you can take to improve your business's energy efficiency. Thanks for watching.